Hey everyone, we are on page 32 in Intercepts and Standard Form. It will be 2 pages, so we'll start on the left side, 32, and go to 33. Okay, so Intercepts and Standard Form, we'll be doing this on the 7th or the 8th of December, depending on what class you're in, and the learning target is I can interpret, sorry I had a little bit of a typo there, interpret intercepts and find them from standard form. Okay, so first things, you already know what y-intercept is, so I thought that that would be an easy place to start. The y-intercept is again where the graph crosses or touches the y-axis, and a little more information is that this will always have an x value of 0, because if the x value is not 0, it'll move off to the left or right, and it will no longer be on the y-axis. And that means that it'll always be in the form of 0, some number. Okay? So that's what a y-intercept will look like. X-intercept is where the graph crosses or touches the x-axis. And this will always have a y value of 0 and be in the form of a number, because that's the x place, comma, 0, right? Because if y is a number, it'll move off the x-axis. It'll move up from the x-axis or down. So the other number has to be 0. Unless, the origin. The origin, 0, 0, notice both of them are 0. This is the only point that is actually both an x and a y-intercept at the exact same time. Okay? So a line, which we've been dealing with lines, will only have one x-intercept and one y-intercept. So if it's the origin, it counts as both. Okay? You can't have more than one of each. Okay. Now, interpreting. So intercepts have a specific meaning in problems. So we're going to look at this problem that Tom buys a boat from a friend and will pay the same amount of money each year until it's paid off. So whatever amount that is, he'll pay that exact same amount every year until it's paid off. And then it says use the graph to interpret the intercepts. So instead of actually like giving you an equation or a table, they give us this graph. And I call this a lazy graph because I only really mark the important stuff. So again, make sure that you're marking everything I am. The y-axis is dollars Tom owes, and that is 12,000 here with a dash, okay? And then the x-axis is number of years, and that is an 8. Okay, so what we're going to do is, dropped a pen, go over what each of the intercepts mean. So we'll just call this part A, and we'll look at the y-intercept. So the y-intercept is where it crosses the y-axis, and since it's the y-axis, the x value is 0, and the y value is 12,000. Okay, and I didn't put a comma in that because I already put a comma here and I didn't want to make it more confusing than it could be. And then what we need to do is essentially interpret this in context. So remember, this is x, this is y. The x-axis is years, so this must be 0 years. And the y-axis here is dollars Tom owes. So I'm going to write money owed. Okay, so that's what's happening in this. So if you want to translate verbatim, like identically word for word, after 0 years, Tom owes $12,000. But what we want to do is really make that a little bit more meaningful, because sometimes you can do a direct translation like in a language, but it's not exactly what you want, like, or mean to say. So because no years have passed, that must be exactly when he bought it. So no years have passed, and that's how much he owes, so that he must have bought it for this amount. So that's what it means in this problem. So yes, 0 years have passed and he will owe 12,000, but what that means is Tom bought the boat for $12,000. And that's what that intercept means. Okay? Then we have the x-intercept, which is where the graph touches or crosses the y, or the x-axis, which is 8. So remember, a point will always go x value first, y value second. So it's 8, 0. Okay? So this is x, this is y. Remember, it's always in alphabetical order. So the x value refers again to years, and the y value refers to money owed. Okay? So, that does not look like a money symbol, does it? There we go. A little bit better. Money owed. So, again, a direct translation tells us that 8 years have passed and $0 is owed. Okay, that's great. But what does that really mean in the context of the problem? Well, if no more money is owed, that tells us how long it took him to pay off. Is it when you're done paying it off? That's when you owe $0, right? So that means it took Tom 8 years to pay back his friend. Okay? So see how we are able to literally decide what it means based on what the point is and what we know each of the axes are, but then we need to actually interpret that in the problem. It's essentially telling us, well, he must have bought the boat for $12,000 and it takes him 8 years to pay it off. Okay? Great. Now, I got a line here. I'm going to switch into standard form, which, don't worry, we'll come back to intercepts. So, for standard form, this is just another way to write the equation of a line. So, we have y equals mx plus b, which is slope-intercept form, because you can literally point to the slope and point to the intercept. Standard form is written like this: ax plus by equals c. And you're going to see probably in Algebra 2 that standard form is something that continues into other types of graphs, but slope-intercept isn't always applicable, but this one is. So the thing to know is, just like slope-intercept, we want to keep x and y as letters or variables. So x and y stay letters or variables. And again, the reason for that is because it's a placeholder and every single point on the line is represented by those. You can take any point and plug it in and it would be true. Then we have A, B, and C. Okay, and what these are numbers. So A, B, and C will be numbers. Okay, so those will be replaced with numbers. Typically we like them as whole numbers, but we'll get to more of that later. But that's the way it is. So x and y, notice that it's in alphabetical order. X comes first, y comes second, equals, and then the number without a variable is on that side. Okay, so now how to graph from standard form. Okay, so we're going to have some steps. The first thing we do is plug in 0 for x to find the y-intercept, because remember, at the y-intercept, x will always be 0. Then you will plug in 0 for y to find the x-intercept, because at the x-intercept, y is always 0. It's the opposite. Then you will plot those two intercepts on the graph, and then you actually just put the line through those 2 points and make sure you extend it all the way across the graph, because here, this made sense for the context of the problem, but you'll see when we do a t-graph, you'll want to extend the line all the way across. And then lastly, this is optional, but when you do this, it makes it really nice and easy to find the slope from those intercepts. And I'll show you that, because when you look at this, I don't see the slope, but what if they want the slope? So we can really easily find it once we've graphed it. Okay? So we'll go through and do some examples. And I've even color coordinated those steps because you know me, I am crazy town. Okay, so here we go. Our first example is to graph 8x plus 4y equals 16. So firstly, I want to show you real quick that this is actually in the form of ax plus by equals c. So that is standard form. Okay, it's not y equals mx plus b, which tells us where to start and how to move. So we have to do it a little bit differently. So step 1 says to make x equal 0 for the y-intercept. So by putting in 0 for x, you're going to find the y-intercept because the point is always 0, comma, the y value. So first thing I like to do is just rewrite the equation as is, 8x plus 4y equals 16. Then we're going to take the 0 and plug it in for x. So I like to put a line down my equal sign anytime I'm solving for something, but we'll have 8, parenthetical promise, put parentheses around that number that you're putting in, plus 4y equals 16. Well, what is 8 times 0? That's just 0. That's gone. It's no more. Goodbye. And we have plus 4y, which just means positive 4y equals 16. Okay, then the last step is we do the opposite. So again, you can ask yourself 4 times what is 16, but if you divide both sides by 4, because they're being multiplied, 4 divided by 4 is 1, so you just have y equals, and then 16 divided by 4 is 4. So what is the y-intercept? That is 0, comma 4. Okay? Then step 2 was to do the opposite of that. Make y equal 0 for the x-intercept. So again, I like to start by just exactly rewriting my equation, not changing anything. 8x plus 4y equals 16. I notice that the more I try to change things and one step at a time, the more I will mess things up. So put a line down my equal sign. Okay, so again, I'm going to take this 0, and this time I'm going to put it in for y. So I'm going to do 8x plus 4, and my parenthetical promise is I'm going to put parentheses around that, equals 16. Well, 4 times 0, what's that? That's just 0. It's gone. I don't need it anymore. So I'm just going to bring down the 8x equals 16. And again, then my last step is either you can, guess and check, or you do the opposite. This is 8 times x. We can divide both sides by 8, which is the opposite, and you end up getting x equals 2. So that means the x-intercept is 2, comma 0. Remember, x always comes first. Okay. Step 3 says to then plot those on a graph. So I'm just going to really quickly draw a graph here and plot those points. This is x, this is y. Okay, so my y-intercept is 4. So I'm going to go on my y-axis and go up 4 because it's positive. 1, 2, 3, 4. So that is 0, comma 4. And here I'm going to go 1, 2 on the y-axis, or the x-axis. So that's 2, comma 0. Okay, now step 4 says to put a line through it and make sure it goes all the way across. So please, no wimpy lines. Don't just do that and be like, oh, I'm done. This line technically goes on forever and ever and ever. So I'm going to make it really long and put arrows on it because it keeps going. Okay, and then remember the optional number 5 was that you can easily find the slope. Okay, slope is rise over run. And we have 2 points right here. I'm going to go from this intercept to that intercept. I went down, so minus 4, and over to the right 2. So my rise is negative 4. My run is positive 2. And that equals negative 2, which again you can do on your calculator if you need to. And there you go. So the main point was to graph it, but you can also find your slope really easily. Okay, now we're going to do one with a negative in it. So now we have to graph 6x minus 3y equals 9. And again, this is in the form ax plus by equals c. The difference is that the b is a negative number, which made that a minus. Okay, same thing though. So now this time I'm going to kind of do more shorthand. So I'm just going to say make x equals 0. Okay, we'll just go a little faster. So that's so we can find the y-intercept. So we have 6x minus 3y equals 9. And I'm going to put in 0 for x. So I have 6 parentheses 0, because you want to do the parenthetical promise because it's times. Then we have minus 3y equals 9. Okay, well, what is 6 times 0? It's 0. It's goodbye. Now we just have this. Don't drop that negative. It's a negative 3y equals 9. And then the last step is that I can do the opposite of multiplying, which is dividing. So I'm going to divide both by negative 3. Make sure you do it by that whole number since it's negative. I have to use the negative 3 and y equals, and again, you can use a calculator for that, but it is negative 3 also. So that means that my y-intercept is 0, negative 3. And if you want to know why I put 0 there, again, it's because the y-intercept will always have a 0, but look, here, x equals 0, so that is 0, y equals negative 3, so the y is negative 3. Okay, then we're going to do the opposite for the y-intercept, or the x-intercept, sorry. So we're going to make y equals 0. Okay, so again, I'm going to just copy the equation as is. Okay, and I'm going to put in 0 for y this time. So 6x minus 3 times 0 equals 9. And 3 times 0, well, what's that? It's 0. That's gone. So the minus 0, I don't need any of it. I just bring down the 6x equals 9. Well, if I were to do guess and check, this one might be a little bit more difficult because 6 times what? 6 times 1 is 6. That's not right. 6 times 2 is 12. So that's not right. But you'll notice if you actually do division here, you get x equals, and then if you want to use your calculator, feel free to do 9 divided by 6, and we get 1.5, and that is totally fine. You're allowed to have decimals as your intercept. So I have 1.5 comma 0, because again, x equals 1.5, so that goes in for x, and way up here, y equals 0, so that goes in for y. Then step 3 tells me that I need to graph this, so I'm going to create a little graph. Okay, and my y-intercept now is negative, so I'm going to go down 3, 1, 2, 3, and that point is 0, negative 3. And then over here, I have 1, 2, nope, I need 1.5. So right there should be good. That is 1.5 comma 0. Okay, then step 4 says to then put a line and make sure again that you go all the way across, make it nice and long, put arrows on it, the whole thing. Okay, beautiful. And then again, I know number 5 is optional, but we'll go do that real quick. That number 5 is optional to find the slope. So again, slope is rise over run. And again, even though that this is a decimal, we're still going to be able to do it because we're going to go up and over. We go up 3, so plus 3, and to the right, so positive 1.5. So that means rise is positive 3, run is positive 1.5, and then all you have to do is do that in your calculator. 3 divided by 1.5, and that gives me 2. So this slope must be 2. So notice here, again, tying back to last week, this slope is negative, and this line is falling from left to right. This slope is positive, and the slope is increasing, or rising from left to right. Okay? So now we just have one more section. Okay, as I told you last time, we would be looping back to vertical and horizontal. So graphing horizontal and vertical lines. So firstly, something to know is that horizontal lines will only have a y-intercept and vertical lines will only have an x-intercept. And you'll kind of see how that works here in a second. So let's start with a horizontal line. So remember, horizontal lines are y equals. Okay, the slope is 0. So it says graph y equals -1. So what we want to do is simply go to -1 on the y-axis and put a horizontal line through it. Remember, the slope is 0. Okay, so it's y equals -1, so it's only going to have a y-intercept of 0 on the x value, -1 for the y value. So 0, -1. Then it cannot have an x-intercept, it's just a horizontal line. So notice how I put it all the way across and I'm putting arrows. So it runs parallel to the x-axis, which is kind of weird. But if it tells you y equals a number, go to that number on the y-axis and then put a horizontal line because it cannot touch the x-axis. Okay? Then it's kind of the same and opposite over here. For a vertical line, it only has an x-intercept. So if we want to graph x equals 3, then what we want to do is go to 3 on the x-axis and put a vertical line through it. Okay, and the x-intercept, there's no y-intercept, is x equals 3, so x value is 3, y value is 0. So go on the x axis, which I realize now that I forgot to put x's and y's on here. So go on the x-axis to 3, because it says x equals 3, and then again, it will not have a y-intercept, so it needs to go just straight up and down. Okay, and there you go. So this is the line x equals 3. This here is the line y equals -1. Okay, and notice I added one more thing down here. It says notice, haha, to have both an x and a y-intercept, so meaning it crosses both of those axes, the equation needs to contain both an x and a y in it. So notice up here, there's an x and a y, and you have an x and a y-intercept. Here, there's an x and a y. Here, you have an x and a y-intercept. But down here, I only have a y, and I only have a y-intercept. Here, I only have an x, and here, I only have an x-intercept. So it kind of helps you out to look at those equations. Okay? Awesome. I will see you all in class.